Good morning, students. I hope your doubts must have cleared in our previous video lesson, which was based on the clarification of your doubts which you have asked in the Google form. Okay, today I'm going to continue our chapter 3, and this is the fourth class of chapter 3. In our previous video lessons of this chapter, we have seen Newton's first and Newton's second law of motion and its examples. Okay, in this class we're going to see Newton's third law of motion, demonstration of Newton's third law of motion, and some examples of Newton's third law of motion. Okay, as we know that Newton's first law of motion gives the definition of force. Newton's second law of motion gives a method of measuring force, and Newton's third law of motion describes the relationship between the force of interaction between the two objects or two bodies. So, what is meant by interaction between any two bodies or any two objects? So, the mutual influence between any two bodies through a force is called the interaction. Clear? That is, whenever two bodies interact with each other, each exert a force on the other. So now we will see Newton's third law of motion, which describes the relationship between the force of interaction between the two objects. So according Newton's third law of motion, to every action there is an equal and opposite reaction. An action and reaction forces act on different bodies. In other words, whenever two bodies interact with each other, the force exerted by the first body on the second body is called the action force, which is equal and opposite to that exerted by the second body on the first body is called the reaction force. Clear? So, in an action-reaction pair of forces, any of two may be called the action and other will be the reaction. Okay, so Newton's third law of motion may also be defined as to every action there is an equal and opposite reaction. You can see in this animated picture. The man is kicking the horse and the horse is also kicking the man back. Here, the action force which is exerted by the man is existing here, and the reaction force which is exerted by the horse on the man in the opposite direction is also existing here. Clear? So, this will be the example of Newton's third law of motion. Another example also you can take, you can see in this picture, the boy and girl is pushing each other by this rope. One is exerting the action force and second one is also exerting the reaction force, but in the opposite direction. Okay, so by all these examples, the following points must be noted carefully, and these points are: both action and reaction are forces, both are forces. Okay, our next point would be both action and reaction forces act simultaneously but on different bodies. For this reason, they can't cancel each other. Clear? Understood? Okay. Our next point would be magnitude of both the forces equal but opposite in direction. Suppose one body is pushing the action force of 5 Newton. So, the second body will also be exerting the force of 5 Newton but in opposite direction. Clear? So, magnitude of both the forces, that means the magnitude of action force and the reaction force will be equal but the direction will be changed. Our next point will be action and reaction forces occur in pairs only. Clear? If they satisfy A on B and B on A requirement, the two forces happen to be equal and opposite does not necessarily mean that they constitute an action-reaction pair. Clear? So, this is the Newton's third law of motion. Now the experimental demonstration of Newton's third law of motion. To verify this law, we have to perform one experiment, and the aim of this experiment is to verify Newton's third law of motion by the two spring balances. So material required are two spring balances, one of 5 Newton and second one is of 10 Newton, and one iron rod. Clear? Now take two similar spring balances A and B, attach the ring of spring balance B to the hook fixed in a wall, and then the hook of spring balance A is attached to the hook of the spring balance B. Now pull the ring of the spring balance A gently to the left. Read both the spring balances. It is found that both the spring balances shows the same reading. You can see here. Clear? They are showing the same reading. Repeat this by applying the pulls of different strength, and it is found for each pulse both the balances shows the equal reading. Clear? Since both the spring balances shows the same reading, we conclude that action and reaction forces are equal in magnitude. Clear? And action and reaction forces act in opposite direction. So this demonstration shows that to every action there is an equal and opposite reaction. Action and reaction forces act on different bodies. This is Newton's third law of motion. Clear? As we know that action and reaction always exist in pairs, but they act on different bodies. This is the Newton's third law of motion. Now we will see the applications of Newton's third law. Action and reactions are involved in walking. How do we walk? When we walk on the ground, we push the ground backwards. This force of push is action. Simultaneously, the ground applies an equal and opposite force on our feet. This force is called the reaction. You can see here action and reaction forces. Both are, acting here. So, it is the force of reaction of the ground on us which enables us to walk on the ground. That's why we are able to walk. Next example is recoiling of a gun. A gun recoils when a shot is fired from it. How? When a gun is fired, the bullet goes out due to the force applied on it through the trigger. This is the action force. According to Newton's third law of motion, the gun recoils backwards due to the reaction acting on it in the opposite direction. This gives a backward jerk to the shoulder of the gunman. You can see here action and reaction force. When a bullet is fired from a gun, the gun moves backward. This is also called the recoiling of gun. Our next example is swimming. In case of a person moving forward during swimming. During swimming, the person swims, or when a person swims, he pushes the water in the backward direction with its hands. This is the action force. As the reaction, the water pushes the person in the forward direction with an equal force. Now, jumping of a man out of a boat. How it happens? When a man jumps out of the boat, he applies some force on the boat in the backward direction. This is the action force, and the boat is pushed away from the bank due to the action of man on it, and the man jumps out of the boat due to the reaction force of the boat on him. Clear? Our next example can be in case of jet aeroplanes and rockets. In jet engines and rockets, the fuel is burned to produce a large quantity of hot gases. These hot gases come out of the nozzle with a great force. This is the action force, and according to Newton's third law of motion, the equal and opposite reaction pushes the jet aeroplanes and rockets forward with a great speed. Force. So these all are the applications of the Newton's third law of motion. And here I am finishing this chapter. I hope you understood everything which is taught to you. So thank you and have a nice day.